And then in this question here, I'm going to use any segment of my choice of any length to create a GIF for polygon with size n is equal to 10. Now integrate each name of the polygon. I'll integrate each name of the polygon of the polygon within my graphic view. So how do I go about it? I'll first construct a circle. So let me construct a circle. So I'll construct a circle of my choice. So I'll hide this. Let me hide all these two since I've not been needing it. Just a minute. Let me hide this. Okay, so I'll construct a circle of my choice. So here's my circle. So my circle here, a circle of my choice. So here is my circle, yes. And I want to construct what I'll be talking about, I'll be inscribing or I'll bring about the inscription of a polygon within a circle. So here's my circle here at the moment. Then with this circle here, here's my point. So I'll introduce slider. Yes, I'll introduce a slider here, where the slider here will be the number of sides for my polygon. For the number of sides for my polygon. So my point here, or the lowest side for a polygon here is a 3. Where 3 is the size for triangle. So 3, and then I'll make my maximum to be 10 per our question. So 10, and then with an increment of 1. So the slider here is the number of sides from our polygon here at the moment. So after finding for it, so we know that here is a point. Then we know that here is also the center, which is also another point. Suppose here is a vertex. Any part of this circumference can also be a vertex for our given polygon. So suppose where I'm standing at the moment here is a vertex, meaning that from this position here to this position here to this position here will give me a polygon, right? And then the angle formed on point A is called the central angle. The angle formed on point A here is the central angle. And how can we find the central angle? It's of the formula of 2 pi divided by m. So I'll represent the central angle by CA is equal to 2 pi divided by n, where n is the number of sides for my given polygon. And I'll press enter. So here at the moment, we have our central angle to be 2.09 when n is equal to 3. So after finding it, and I'll come back to this option here, which is rotate around point. So I'll select this rotation around point, come and stand on point B, click on it, and move to point A, click on it. And I'll represent, or I'll get rid of this and introduce CA, which is my central angle. So I'll click on OK. And there's a new point on our circle, which is B complement. So I can join this point together with the use of the polygon, but I will choose a regular polygon. So I'll join point B to B complement together. And then I'll represent the vertex with n, which is the number of sides. Okay. Here we have a triangle at the moment, as you can see. So let's watch it. Suppose I increase n to 4. I have a quadrilateral, n to 5, pentagon, hexagon, heptagon. So this one is nonagon, and then decagon. So right now at the moment, our n is 3, which is a triangle. So we've gotten our triangle at the moment here. So let's make a few adjustments. So let's get rid of all these values since I'll not be needing it. So I'll hide all these variables. So I'll hide all these variables since I'll not be needing it. So show objects and get rid of them. So I get rid of all these points since they are not necessary in our work. And then after that, also we also hide the circles. Let's hide our circle for now. So right now, before I hide my circle, what you have here is an inscribed polygon. That is, there's a polygon within a circle. So we call it inscribed polygon. So let me hide the circle for now. So this is my polygon. Let's animate it to see how it looks like. So watch it. So you can see, so we have animated it, and then the polygons are changing. But with our question, we are supposed to introduce the name of all these polygons within our work. So how can we introduce the name of all these polygons within our work? Okay, there's an easy way. Let's start. So suppose right now at the moment we have n is equal to 3, where here is a triangle. We can come back to our test at the moment. Select test, come inside within the triangle and click in it, and then enter our triangle. That is the name of this polygon. So triangle. Then we press enter. So here's our name at the moment. Then we enter all the names. So the next name will be a square. The next name here, we have to enter all the names up to the 10 sides. So square, move on to pentagon. Move on to pentagon. Move on to hexagon. Hexagon, which is the third side. So let me pause for now. So right now I have my triangle here. Let me move it to another side. I have my triangle here. This is my triangle. My triangle is n is equal to 3. I want to make it in such a way that when n is equal to 3, only the triangle will appear. When n is equal to 4, only the square will appear. When n is that of 5, only that of pentagon will appear. So how can I go about it? I can come back to my triangle here, click in it, and then move on to object properties, where I'll move my position here to advance. So I'll see that triangle, I'll see n is equal to 3. Then we press enter. Do you see? N is equal to 3. So I'll type in n is equal to 3, then we press enter. Then move on to the same for this property here. So move on to the square. And we see n is equal to 4. We press enter. You can see that the square is gone. Do same for this position here also, that n is equal to 5. Hence is gone. Do same for this. N is equal to 6. It's gone. So we can see that now all the names that we give here within this shape here is gone. Let's introduce the rest of the names at the moment. So we have heptagon, octagon, nonagon, decagon. Okay, so we do same for all this. So when n is equal to 7, when n is equal to 8, when n is equal to 9, yes, when n is equal to 8, and then our last shape, when n is equal to 10. Okay, so let's close that. So let's see. That's what we have here. So watch here. So I believe we can see it. So as the name changes, so that the number of sides also changes. Okay. So let me position all these shapes well. Then position all these shapes well. So I'll make this one large. This one large also. I'll make this one large also. Base position. I'll make this one also large. Yes, I want to make it more visible. So with this one also, I'll make here large. Make it also large. Okay. So this one is a long process, but that's how to go about it. You are just making a few changes to the writings. Okay. So yeah,